Hi guys, today we are going to be solving quadratic equations. A quadratic equation is the special name given to an equation of degree 2. There are different ways to solve quadratic equations. We can solve them by factoring, by using the square root method, by completing the square, and the quadratic formula. Today we are going to focus our energy on solving quadratic equations by factoring and using the square root method. And to minimize the length of the videos, in a later video we are going to solve them by completing the square, and a video thereafter will introduce our fourth and final technique, which is a quadratic formula. Alright, so let's go ahead and do this. So let's go ahead and write down the first problem. So we're going to do two problems right now. So the first problem reads x squared plus 5x equals -6. Okay, so the question is, how can we solve it? So for me, what I like to do first is I'm gonna ask myself, is this factorable? Can I solve it by factoring? So I'm gonna assume that it is until I realize that it's not. Okay, cool. So to solve a quadratic equation by factoring, our first goal is to set it equal to 0 so we can then factor. So let's go ahead and work our magic to set the equation equal to 0. We will add a 6 to both sides. And when we do that, will give us x squared plus 5x plus 6 is equal to 0. Fantastic. So now the question is this factorable? I don't know. I'm going to assume that it is until I realize that it's not. Okay, so I know that you are a factoring genius, but I'm a little slow, so I'm going to do a corresponding x game. Okay, so the corresponding x game, we want factors of c that add up to b. So remember, this is a trinomial of the form ax squared plus bx plus c. So the leading coefficient, namely 1, that's our a, coefficient of the middle term is b, constant term is c. So I want to know, does this x game have a solution? So we want factors of c that add up to b, factors of 6 that add up to 5. So the sides have to multiply to 6, and at the same time the sides have to add up to 5. If this x game has a solution, then the trinomial is factorable. If it doesn't have a solution, then the trinomial is not factorable. So to complete this x game, factors of 6 that add up to 5, I believe is 2 and 3. You can say 3 and 2. It's okay to switch the sides. Why? We can switch the sides because both multiplication and addition are commutative. So let's go ahead and throw down our sets of parentheses. So the product of the first term should give us x squared. Let's go ahead put the x and x. Then to complete the binomial factors, we're going to use the sides in the x game to complete the binomial factor. Sorry for the redundancy. The question is, do we have to show this x game? No, if you don't need it, I don't need it. Okay, cool. So now at this point, how do we proceed? To solve a quadratic equation by factoring, 1, set it equal to 0, factor completely, and then apply the zero factor property. So the question is, how does that what's so special about the zero factor property? So the zero factor property states this: if a product equals 0, then there's no way around it. One of these factors has to equal 0. Either the first factor equals 0 or the second factor equals 0. And I know that you know that we have 0 times 0 equals 0, but we're going to ignore that third case, because if both factors are 0, then we're not going to have a variable. So I'm going to do a quick example, okay, to illustrate the zero factor property. So let's just say that I have 0 times 3, and then for spiciness, I'll put -3 times 0. I know that you know that the product of 0 and 3 is 0, and the product of -3 and 0 is 0. Okay, so what the zero factor property is saying is this: if you have a multiplication problem and that product equals 0, the only way that the product is gonna equal 0 is if one of these guys equals to 0. Either the first number or the second number equals 0. So either the first factor equals 0 or the second factor equals 0. I told you why we ignore the third case scenario. Okay, so coming to our problem, how do we solve a quadratic equation by factoring? So 1, set the equation equal to 0, factor completely, and then apply the zero factor property. So if a product equals 0, then there's no way around it. One of these factors has to equal 0. Either the first or second factor equals 0. So let's go ahead and write it out. So either the first factor equals 0 or the second factor equals 0. If the first factor equals 0, that's going to give us a solution of -2. And if the second factor equals 0, then that's going to give us a solution of -3. So bear in mind that the degree is 2, so we're expected to have 2 solutions. We have 2 solutions, so we're good. Do me a favor, it's a little bit hard to look for the answers all over the place, so let's go ahead, take the union. In English, give me a combined statement. We're solving for x, so we're going to put x equals, and then I just want you to list your solutions and in any order of your liking. You know, if we look at the back of the book, of course they're going to write it in order from smallest to largest. For me, I just write them in the order that I find them. Okay, cool, fantastic. Let's go ahead, knock out problem B, which will wrap up not the video, but it will wrap up the set of exercises. So problem B, we have x squared minus 9 is equal to 0. Okay, so let's go ahead and do this. So we have a degree 2 equation or quadratic equation. How can we solve it? So you know me, factoring is like my go-to. So the question is, to solve a quadratic equation by factoring, what are we going to do? The steps: set the equation equal to 0, factor completely, and then apply the 0 factor property. So 1, set the equation equal to 0. Done. Factor completely. Now, we're not going to use the x-game because the x-game is reserved for trinomials. We have a binomial minus, so I'm going to ask myself, do I have a difference of squares? So let me remind myself. Difference of squares. Okay. So the difference of squares says this: if this is your problem, then this is your answer. Okay. So we call it difference of squares because we're subtracting 2 squared terms. And if you have a difference of squares, this is what it's gonna factor to: a plus b times a minus b, or a plus b times its conjugate. So I know that you can recognize this as a difference of squares, but for me it's really hard to eyeball that. So I'm gonna do what I call the mold, M-O-L-D, because my accent gets in the way. So I want to know, do I really have a difference of squares? So I'm going to do a mold for a difference of 2 squared terms. And if I fit the bill, then yeah, we do have a difference of squares. Now, x squared is a perfect square because it's the square of x. 9 is a perfect square because it's the square of 3. So in this case, we do have a difference of squares where the first base is x and the second base is 3. So we have a and b identified. So the difference of squares says this: if this is your question, then this is your answer. Let's go ahead and factor a plus b times its conjugate. So this should factor to x plus 3 times its conjugate, x minus 3. Okay. How do we solve quadratic equations by factoring? 1, set the equation equal to 0. 2, factor completely. 3, apply the 0 factor property. So if a product equals 0, again, there's no way around it. One of these factors has to equal 0. Either the first or second factor equals 0. So if the first factor equals 0, that's going to give us a solution of -3. So either the first or second factor equals 0. And if the second factor equals 0, then that will give us a solution of +3. The degree is 2, so we're expected to have 2 solutions, so we're good. Let's go ahead, take the union, or in English, just give me a combined statement. Okay, so the solutions are -3 and +3. Now, I know what you're thinking, like, oh, can't we do problem B a little bit different? Yeah, we sure can, but I didn't want to mix up a lot of things at once. So we're going to introduce the square root property so we can then solve the same equation by using the square root method. Okay, so let's do this. So I don't like to point to things, so I'm going to just copy this over. Okay, so the square root property says this: if I have something squared equals a number, what am I going to do to get rid of a square? To get rid of a square, we're going to go ahead, square root. And then we have different ways to go about it. We can say the square root of x squared by definition is absolute value of x, but that's not how it's written in textbooks, so I'm going to keep it like how the books write it. So a workaround is when you square root both sides, you're going to have to insert this funny looking symbol. Okay, so that symbol is read as plus or minus. It's kind of hidden because I didn't anticipate the space, so I'm going to circle it. Okay, so that will give us the square and the square root undo each other, and that will leave us with x equals positive or negative, whatever the square root of n simplifies to. Okay, so what this is saying is this: the answer is given by positive radical or negative radical. So we read this as plus or minus. So we have x equals positive square root of m or negative square root of m. Okay, so let's go ahead and knock out that same problem one more time. So we have x squared minus 9 is equal to 0. And the question is, when is it that we can use the when is it that we can solve a quadratic equation by using the square root method or square root property? Same difference. You can use this technique when you have a squared part and a number part. The reason why I say squared part is because this is not limited to a variable squared. It could be a variable squared, or it can be a quantity squared. Okay, so if we have a squared part and a number part, extra number parts are fine, you're good. What we don't want to see is a loose linear term, so like a loose x. Okay, what do they say? No bueno. Yeah, cool. So let's do this. So the question is, how can we solve a quadratic equation by using the square root method? So your first goal is to isolate the squared part. If you're not with the squared part, you gotta go. Okay, so squared part on one side, number on the other side. Let's go ahead, add 9 to both sides. We take our time, add 9 to both sides, and that will leave us, where am I? That will leave us with x squared is equal to 9. So first goal complete. So to solve a quadratic equation by using the square root method, 1, isolate the squared part, and then 2, now apply the square root property. Okay, so the square root property says this: to get rid of a square, let's go ahead, square root. And whenever we square root, we insert our plus or minus. So a lot of students will say, oh, the square root of 9 equals positive or negative 3. But that's a lie. The square root of 9 is 3. Punch it in your calculator. The square root of 9 is 3. Your calculator will not say plus or minus 3. Okay, so just be careful. So on the left side, the square and the square root undo each other. And that will leave us with x equals positive or negative, whatever the square root simplifies to, and the square root of 9 simplifies to 3. So that's our answer. But I always tell students not to submit their answer with the plus or minus symbol, because it doesn't highlight that we have 2 solutions. I need to make sure that you understand that this is 2 solutions, not just some funky answer. Okay, so we have x equals plus or minus 3. So this reads x equals plus this or minus that. So x equals plus this, so positive 3 or negative 3. So it's the same exact problem we just knocked out, so we need to get the same exact answer. So before we got, where am I? Let me zoom out. Before we got negative 3 and positive 3, what do we have? Also negative 3, also positive 3, in a slightly different order, but we're good. Cool. So I know that we can't be pros after one problem, so we're going to do 2 more problems illustrating this technique, and we're good to go. Bear with me. Okay. So yeah, so to put a little housekeeping, we just knocked out how to solve an equation by factoring. We're going to continue the square root method, and then completing the square and quadratic formula, we'll table it for a later video. Okay, so we are asked to solve each equation. So you can solve both of these equations however you like. It doesn't say what technique to use, but in all honesty, although I love factoring, I'm always gonna ask myself, can I take a shortcut? It's not a shortcut, that's just how I speak. When it comes to solving quadratic equations, I always ask myself, can I take a shortcut? Can I use the square root method? If the answer is yes, then I'm gonna take it. And if the answer is no, then I'm a factor. And if I can't factor, then I have my backup plans. Okay, so I'm gonna ask myself, can I take a shortcut? Can I use the square root method? I don't know. Do we have a squared part? Yeah, cool. Do we have a number part? Yeah, more than one, it's okay. What I want to focus on is do we have a loose linear term, like a loose x? And the answer is no. So we can use the square root method. So to solve by using the square root method, our first goal is to isolate the squared part. If you're not with the squared part, you gotta go. So let's go ahead, subtract 6 from both sides. And when we do, that will leave us with the square of x minus 7 is equal to negative 6. Fantastic. Work your magic. Let's go ahead, let's go ahead, get rid of the square. To get rid of the square, we're gonna go ahead square root, because the square and the square root are inverse operations. Let's go ahead, insert our plus or minus. So the square and the square root undo each other. So that will leave us with the x minus 7 is equal to positive or negative, whatever the square root of negative 6 simplifies to. Now, I know you're on it and you can probably simplify this in your head, but I can't. So I'm going to bust out a thinking area. So when it comes to simplifying square roots of negative numbers, the first thing we want to do is to fix it so the radicand is positive. So we are going to replace the square root of negative 1 with the imaginary unit I. And then we're going to multiply it by the leftover radical, which is square root of 6. Okay, the square root of 6 does not contain a perfect square factor, or in English, we can't simplify it anymore. So that's it. This is what the square root of negative 6 simplifies to. So we have x minus 7 is equal to positive or negative square root of negative 6, which simplifies to I times the square root of 6. Fantastic. Let's go ahead continue to work our magic to isolate the variable term. To undo the subtraction by 7, let's go ahead add it to both sides, and that will leave us with x equals 7 plus or minus I square root of 6. What I want to point out is this, we have a non-real solution. Why? Because we have an I in the mix. So I know that we could have solved this however we like. If we would have done factoring, this would have not been factorable because of the non-real solution. Only when the answers are rational, then it's factorable. Okay, I said too much. So we have a non-real number solution. So when it comes to non-real solutions, we need to make sure that we write them in standard form, a plus bi. Real part followed by pure imaginary part. What do we have? Real part followed by pure imaginary part. So let's go ahead and get our full credit. So we're going to submit the answer without the plus or minus symbol. Bear in mind that a lot of textbooks submit the answer like this because I'm assuming that they want to save money on ink, okay, or on paper too, but it's okay. We have space to split it. So the first solution, we have x equals 7 plus this. Solution number 2, 7 minus that. So let's do this. So we have 7 plus I square root of 6. And the other solution is 7 minus I square root of 6. Fantastic. I checked it at my house. Cool. So let's go ahead and knock out the second problem, and that'll be the end of this video. Cool. So problem B, we have 2 times the square of x minus 3 less 22 equals 10. So again, if you want to try to solve by factoring, go for it. But look what happened. We had a non-real solution, so we couldn't solve by factoring. So again, I'm always going to ask myself, when it comes to solving quadratic equations, can I take a shortcut? Can I use the square root method? And if I can, cool. And if I can't, then we factor. And then if we can't factor, then we take out our backup plans. So I'm like, okay, can I really solve by using the square root method? I don't know. Do I have a squared part? Yeah. This pesky times 2, we could get rid of it. Okay. Do I have a squared part? Yeah. Do I have a number part? Yeah. Extra number parts are fine. What I want to point out is this. We don't want a loose linear term like, let me take out the problem that we did earlier. Okay. So for this problem, we couldn't solve by using the square root method, because of this loose linear term, this 5x. Okay, we have a squared part, we have a number part, but this pesky x term is in our way, and that is the reason why we can't use the square root method. Okay, I digress. Let's come to our problem. So to answer the question, can we solve it by using the square root method? Yeah, because we have squared parts and number parts, no loose x's, no loose linear terms. So our first goal is to isolate the squared part. So if you're not with the squared part, you gotta go. Let's go ahead, add 22 to both sides. And that will leave us with 2 times the square of x minus 3 is equal to, where am I? I think it's like 32. Keep your cool. We haven't quite isolated the squared part, so no square rooting. To get rid of the times 2, let's go ahead, divide both sides by 2. And that will leave us with a square of x minus 3 is equal to 16. Cool. We have isolated the square part, so now let's go ahead, apply the square root property and square root both sides. So to get rid of a square, we're going to go ahead square root, and then at this line, not at the next line, I need you to put your plus or minus. So when we do, the square and the square root undo each other, and that will leave us with x minus 3. Okay, which was the radicand. All right, x minus 3 equals plus or minus whatever the square root of 16 simplifies to. The square root of 16 will give us 4. So let's go ahead, work our magic, and isolate the variable. To get rid of the minus 3, inverse operation of subtraction is addition, or in English, opposite of subtraction is addition. So the sum of negative 3 and 3 will give us 0, and that will leave us with x equals 3 plus or minus 4. Bear in mind that your answers should never be submitted with the plus or minus, so let's go ahead and split it. So we have x equals 3 plus or minus 4. So solution number 1, x equals 3 plus 4, and the other one 3 minus 4. So we have x equals 3 plus 4, and the other one 3 minus 4. Last time I checked, 3 plus 4 is 7. And 3 minus 4 is negative 1. I want to point out is this, since 7 and negative 1 are both rational, we could have solved it by factoring if we wanted to, but check it out. I think it would have taken us a little bit longer, because if we try to solve by factoring, we will have to square the x minus 3, distribute the 2, and then follow the procedure, set it equal to 0, and then factor. And if we didn't make a mistake, then we will have the same answers. But yeah, you solve it however you want if the directions don't specify what technique to use. Okay guys, that's my time. Thanks. So check it out. We were originally gonna do two problems, namely A and B, but why don't we go ahead do C and D, and then we'll be out. Okay, so remember, we are not specified in terms of what technique we are used to solve each equation. We solve it however we like. Okay, whenever I see a degree 2 equation or quadratic equation, I'm naturally drawn to like, oh, you know, can I solve by factoring? But I'm gonna ask myself this: can I take a shortcut? Again, it's not a shortcut, that's just how I speak. Can I take a shortcut? Can I use the square root method? So we can use the square root method whenever we have a squared part, or whenever we have a squared part and a number part. So again, for problem A, we had a squared part, number part. Extra number parts are cool. What we want to highlight is that we don't have a loose linear term or loose x. Okay, for problem C, we don't really have a squared part, whether it's a variable squared or a quantity squared. But you know what? We can pretty much get rid of that times 3 in a bit. Okay, so we're gonna go ahead use the square root method. So to use the square root method, let's go ahead. Our first goal is to isolate that squared part. If you know what the squared part, you gotta go to undo the addition by 64. Let's go ahead, subtract it from both sides. You know, always do the inverse operation. Who speaks like that? You know, just do the opposite. Okay, difference of 10 and 64 will give us negative 54. When we take our time to get rid of the times 3, work your magic. To get rid of the times 3, let's go ahead, divide both sides by 3. And who has a calculator? After we divide both sides by 3, that will give us x squared equals, punch it in for me, I think it's negative 18. Fantastic. So our first goal is complete. Remember, in order for us to use the square root method or apply the square root property, we gotta isolate the square root part, and we gotta isolate the squared part and then take it from there. So now to get rid of the square, what are we gonna do? Just do the inverse operation. So undo the square, we're gonna go ahead square root, and anytime we do the square root at this point, not the next line, at this same line, we're gonna go ahead insert our plus or minus symbol. So when we do on the left side, the square and the square root undo each other, and that will leave us with x equals positive or negative, whatever the square root of negative 18 simplifies to. So I'm going to go ahead, bust out a thinking area on the side, or we could probably just do it here, you know. All right. When you have a negative radicand, or in English, whenever you're square rooting a negative number, your first goal is to make the radicand positive. So what are we going to do? We are going to replace the square root of negative 1 with the imaginary unit I. Okay, so that will leave us with I times the square root of whatever we're left with. Let's bring down the rest of the problem. Okay, so you simplify the square root of 18 however you like. It would be nice if we can think of a perfect square factor, and I think 9 is it. Okay, so we're gonna rewrite a square root of 18 as the square root of 9 times the square root of 2. Let's go ahead, simplify whatever we can. That's the ugliest I ever. Remind me not to try to fix things. Okay. So when we take our time, the square root of 9 simplifies to 3, and that is being multiplied by the square root of 2. So that is our answer. Let's just go ahead and rewrite it so it looks aesthetically pleasing. Okay, so that will leave us with x equals plus or minus I times 3 is the same as 3 times I, and that is being multiplied by the square root of 2. When you check your answer in the back of the book, your book will write the answer as x equals plus or minus 3i root 2, okay? But if you're writing with me, that's one of my pet peeves. I don't want to see the plus or minus in the answer because that doesn't highlight that we have two distinct solutions. Let's clarify. I need to make sure that you understand that this represents two distinct solutions, not just some funny solution. So we're going to write this as x equals positive this, comma, or negative that. Okay, so x equals positive 3i times the square root of 2 and negative 3i times the square root of 2. So remember, solving quadratic equations by factoring is nice, but that technique only works if it's possible to factor. Okay, so if we can factor, then we can solve by factoring, and if we cannot factor, then we gotta use another technique. Okay, so I said we were gonna toss in C and D. That's C. Let's go ahead, do D, and then we're out. I'm trying to fix this, sorry. Problem D. Okay, so when you see problem D on a quiz, test, or homework, you have two options. Option 1, expand all factors. So square the 3x plus 1, distribute the 4, and then you hope that it's factorable. Okay, if it is, then you factor, and if it's not, you're gonna have to take a pause and think of something else. But before we check to see if it's factorable, I'm going to ask myself, can I take a shortcut? Can I use the square root method? I'm like, I don't know. Do I have a squared part? We sure do. Okay. Do we have, well, it's multiplied by 4, but we can get rid of the 4 in a bit. Do we have a number part? Yeah. What about this extra number part? That's fine. What I want to highlight is that we don't have like a loose linear term or loose x. So let's go ahead solve this by using the square root method. So remember, our first goal is to isolate the squared part. If you're not with the squared part, you gotta go. I was gonna do a triangle, but I lost my train of thought. So if you're not with the squared part, you gotta go. So let's go ahead and do the subtraction by 24 by adding it to both sides. After we add it to both sides, that will leave us with 4 times the square of 3x plus 1 is equal to, oh, who has a calculator? Oh, subtraction is not my friend. I think that's 8. So someone said, oh, can we square root both sides at this point? And the answer is no. Why not? Because our primary goal is to isolate the squared part. Okay, so to get rid of the times 4, let's go ahead, divide both sides by 4. And that will leave us with square of 3x plus 1 is equal to 2. Fantastic. Now that we've isolated the squared part, now we can apply the square root property. So the square root property says this: to get rid of a square, let's go ahead, square root. And remember, at this point, we have to insert our plus or minus. If we wait until the next line, that's actually incorrect. So after we square root both sides, we're going to tell the world that the square and the square root undo each other, and that will leave us with the radicand of 3x plus 1 is equal to plus or minus, so positive or negative, whatever the square root of 2 simplifies to. Now, unfortunately or fortunately, 2 does not have a perfect square factor, so that's it, it's already simplified. Now, the degree of the resulting equation is 1, so let's just go ahead, old school it, variables on one side, non-variables on the other. To undo the addition by 1, let's go ahead, subtract it from both sides. And then someone asked me, how should we write the, what is it, left, right? The right side. And I'm like, write it however you want. I'm going to do a thinking area. So some students like to write like you write it from top to bottom. So plus or minus square root of 2, then the minus 1, which is okay. Okay, but for me, it's not like aesthetically pleasing. So like if it doesn't look pretty to me, it's just not gonna look nice. Okay, but if this works for you, then it works for me. The real reason why I don't like it when the radicals in the beginning is because sometimes with tired eyes I get nervous and accidentally extend the radical, and then I'm like, oh look, simplify. No, don't do that. Okay, so for that reason, pretty much I put the radical part at the end. Okay, so we have -1, then we have plus or minus the square root of 2. Fantastic. So we have variable terms on one side, non-variables on the other. Okay, so for the grand finale, to get rid of the times 3, let's go ahead and divide both sides by 3. And when we do, that will leave us with x equals -1 plus or minus the square root of 2 over 3. Fantastic. That's our answer. So the question is, we got a fraction. Is it simplified? It sure is. Why? That's because 1, root 2, and 3 don't have any factors in common other than 1. Let me cross this out because it's my way. Okay, so our fraction is reduced, but remember, we want to make sure that we want to highlight that we have 2 distinct solutions. So please don't write your answers with the plus or minus symbol. So our answer reads x equals -1 plus or minus the square root of 2 over 3. Let's go ahead and split it. So one solution, x equals -1 plus the square root of 2. Then we divide that by 3, comma. And the other solution is -1 minus the square root of 2 all over 3. Okay, so I said we were going to do 2 more problems. That is C and D. So we're out. Thanks.